Let's continue with this our lecture series on NEET PYQ. Our last lecture on motion in plane, or you can say motion in two dimensions. So let's start with our first question in this particular new worksheet. Okay. So our next question says the position of a particle is given by this function RT. Okay. Here, and where t is in second and r is in meter, find the magnitude and the direction of the velocity vt at t equal to 1 second with respect to x-axis. Okay, with respect to x-axis, what you have to find? Magnitude and the direction of velocity. Okay, so both we have to find. First, what we will do is to figure out the velocity, we will differentiate this function. So v will be equals to d by dt of r, correct? And that will be equals to d by dt of 4t I cap plus 2t square j cap plus 5k cap. I hope this is clear, right? We are differentiating it with respect to time to get the value of velocity. So differentiation of 4t, that will give us 4 I cap, because we are differentiating with respect to time. Here it will give us 4t j cap, and derivative of 5k, it's a constant, so you will get straight away 0. So velocity function will be our this one. Now they are saying find the magnitude and the direction. So first we'll find the value of magnitude. So magnitude of velocity at t equal to 1 second, let's substitute t equals to 1 here. So velocity vector will be equals to 4i plus 4j cap, correct? This is our velocity vector. If this is our velocity vector, let's find the magnitude. So magnitude of velocity will be equals to root under 4 square plus 4 square. So this will be equals to root under 16 plus 16. And that's 16 taking common out, it will give you 4 root 2 meter per second, right? That you can solve yourself. Very simple it is, 4 root 2 meter per second. Along with that, they are saying what will be the direction and the with respect to x-axis, what will be the angle it is forming, right? So to figure out the angle, we simply know this. Tan theta is nothing but the ratio of velocity of y-axis upon velocity of x-axis, right? Tan theta is vy by vx. Now what is vy? Our vy, as you can see, the velocity is 4 along y-axis, and along x-axis velocity is 4. So when you divide both, you will get 4 upon 4. And what is the value of tan theta being 4 by 4 equals to 1? For what angle tan theta is 1? Our tan theta is 1 at 45 degree. So correct answer for this particular problem is option A. I hope this is clear. Quite interesting and very simple problem. Let's see the next one. Great. Our next problem here says a ball is projected from a point A with velocity 20 meter per second at an angle 60 degree. Okay, as shown in the figure. So I think there is a figure which is missing. So let me just draw the figure. Just give me 1 second. So let me draw the figure from the book itself. Okay, great. So the figure from the book here is, let's say this is our figure. Okay, so I'm drawing it here, and here it is going from like this. This is point A, this is point B over here. Okay, and what is given here we are finding, and this is point C here, and the velocity, initial velocity is 20 meter per second, which is here 20 meter per second, and it is forming what angle? 60 degree. Okay, this is the diagram, okay, which we missed. Okay, let me come back to the problem. The problem says a ball is projected from point A with the velocity 20 meter per second at an angle 60 degree to the horizontal direction. At the highest point B, at this point B shown in the figure, the velocity v meter per second of the ball will be, so we have to find the velocity at highest point. Now we have done one problem, similar problem in the previous lecture. In case if you have not seen the previous lecture, link is in the description, you can watch it. Let me come back to this. So velocity at this point, if you come back here, if you reach here at point B, if the projectile reaches at point B, its velocity, which velocity becomes 0? The vertical velocity, vertical component will be 0. If there was some velocity along the vertical direction, the projectile should have gone little up, okay, little higher, but it is not going up and it is coming back down because the vertical velocity component is reducing to 0 at this point, but horizontal is still there. So at that point, at velocity at point B, okay, will be velocity along x-axis. Okay, so what is that? That will be our u cos theta. Okay, that remains same along the horizontal direction. So horizontal direction, it will be u cos theta here, u cos theta. And what's our u? U here is initial velocity. What is our initial velocity? 20 meter per second. And cos of what angle? 60 degree. Cos 60 is half, so this will be 20 into 1 by 2, and that will be equals to 10 meter per second. That's our velocity, correct, at this point B. So correct answer for this question is B. Quite easy problem, straightforward problem, right? Let's see the next question. Great. Our next question says a ball is projected with a velocity 10 meter per second. So initial velocity here is 10 meter per second at an angle of 60 degree. So theta is 60 degree, fine. Its speed at the highest point. Quite similar problem. So straight away we know that our highest point, the velocity will be equals to u cos theta. Okay, just now we have done one problem. So u here is 10 and cos 60 degree is half. Cos 60 degree is half. So this will be 5 meter per second. That's our velocity at the highest point. Let me repeat again. This is the horizontal component of the velocity at the highest point. Vertical component, if they ask, it is 0, right? So be very careful with that. Let's see the next question. Great. Our next question says two particles A and B are connected by a rigid rod AB. The rod slides along perpendicular rail as shown in the figure. Fine. AB is a rod and it's sliding down. Okay. The velocity of A to the right is 10 meter per second. Okay. What is the velocity of B when the angle alpha is 60 degree? Understood? The question is here, we have to find the velocity of B. Now, what is velocity of A? It is given 10 meter per second. Now, if you take this right angle triangle, tan of alpha, what is our tan of alpha? Perpendicular upon base y by x, correct? Let me repeat here, y here, let me call it as C, okay? So, y here is the perpendicular direction and x here is the horizontal direction. Tan theta is y by x, where y is what? BC and AC, correct? Now, if I cross multiply them, this will give me AC into tan alpha is equals to BC. I hope this is clear. When you cross multiply both of them, what will you get? You will get AC into tan alpha equal to BC. Now, if I differentiate both, alpha is constant, angle is not changing here for the time being. So, if alpha is fixed, d by dt of AC, rate of change of AC into tan alpha will be equals to d by dt of BC. I hope this is clear. Now, what is DAC? Dx by dt. And what is dx by dt? How the velocity of A is, how it is changing with respect to that? 10 meter per second. So, it will be 10. And what is tan alpha? Alpha is 60 degree. So, tan 60 degree. And that will be equals to how BC is changing, right? They have asked this. So, tan 60 is nothing but root 3. So, 10 into root 3, that will be equals to d by dt of BC. I hope this is clear. Now, what is root 3? Root 3 is 1.73. When you put the value, you will get 17.3 meter per second. And that is how our BC is changing or the rod is falling down. So, correct answer is option D. Clear it is? I hope this is clear. Let's see the next question. Great. So, our next question says, if a body A of mass m is thrown with a velocity v at an angle of 30 degree to the horizontal, and another body B of the same mass is thrown with the same speed at an angle of 60 degree to the horizontal, the ratio of their horizontal ranges will be, so range formula, let me recall it for you, R is nothing but u square sine 2 theta upon G. We will make use of this formula, correct? Now, if this is the range formula, let's find the range for the first body. That will be RA, that will be UA, initial velocity with which the first object is thrown, first projectile is thrown, sine 2 theta 1 upon acceleration due to gravity will be same. Why? Because both are projected from the earth. RB, that will be equals to UB square sine 2 theta 2 upon G, correct? Now, question is saying that both are projected with the same velocity v. So, UA is v and UB is also v. So, when you divide both of them, you will get RA upon RB, v gets cancelled. So, v square gets cancelled, G cancels. You left with sine 2 theta 1 upon sine 2 theta 2. Be very careful, there is no role of mass, okay? So, we will directly put the angle 30 degree here. It will be sine 2 times 30, that is 60 degree, whole divided by sine 2 times 60 degree, that is sine 120. Now sine 60 is nothing but root 3 by 2 and sine 120 is also root 3 by 2. Both of them gets cancelled and correct answer is 1:1. Let me repeat it for you. It's root 3 by 2 upon a root 3 by 2 and that's nothing but 1:1. That's our final answer. Let's see the next question. Great. Let's see our next one. The question says the speed of a swimmer in still water is 20 meter per second. So a swimmer, he travels, speed of the swimmer is 20 meter per second. That's the speed. Okay, fine. The speed of a river water is 10 meter per second. Now this is a question from relative velocity in 2 dimensions. Okay, and is flowing due east. So let's say the river is flowing in this direction. Okay, this is our velocity of river in this direction. Great. Okay, if he is standing on the south bank and wishes to cross the river along the shortest path, the angle at which he should make his strokes with respect to north is given by how much, right? So this is the velocity of a river, and if if he wants to travel, okay, okay, let's say let me draw here the river. Let's draw the river. Let's say this is our river here. So let's say this is our river here. Yeah, this is our river in this direction. The river is here. Okay, now if this is the river and the person wants to travel, this is the velocity along in this direction the river will be, and let's say if he wants to reach from, he is standing over here, this person standing over here, and he wants to reach from this any point A to point B, correct? Okay, now if he starts traveling in this direction, what will be the natural tendency of this river flow? It will try to throw this person on the right hand side, right? If I am moving straight, the throw of this river will throw me in this direction. So instead of reaching at point B, I will reach somewhere at point C. This is obvious, correct? It is, because the water flow will also throw me in this particular direction. Okay, so instead of reaching at B, I will reach at C. Better is I should go in this direction. In which direction? I'll go in this particular direction. If I move in this direction with that velocity, I will somehow reach at point B. So let's find at what angle I should go in this particular direction to reach at point B. So let's make vectors. This is our velocity VR, correct, in this direction. And let's say this is our here. This is from A to B. Okay, let's say I am reaching from A to, I want to reach at B perpendicularly. And I started walking from A and I am moving with in this direction. This is my velocity of this person or velocity of swimmer, correct? I have to figure out this angle theta at which I should walk or I should swim so that I can reach up to point B. Clear it is? How I got this? I hope this is clear. Okay, so I have to obviously move in this direction so that the throw of this river should get me to point B, correct? So this will be the situation. If this is VR and this is VS, from here we can make use of sine theta. What is our sine theta? So sine theta is perpendicular upon hypotenuse. So if you look at this particular triangle, this will be perpendicular and this is hypotenuse, right? So velocity of river upon velocity of swimmer. The ratio of that will give me sine of angle theta. And I'm looking for the theta only. And what's the velocity of river? So it's 10. Velocity of swimmer, 20. This will give me 1 by 2. So sine theta is 1 by 2. For what angle sine theta is 1 by 2? Sir, sine theta is 1 by 2 at 30 degree, correct? So correct answer for this is 30 degree and 30 degree west. I hope this is clear. On the west side. Clear it is? And obviously it has to move towards west, because if it will move on the right hand side, okay, it will reach up to point C instead of reaching up to point B. And we have to reach up to point B. I have to walk at that particular or swim at that particular angle. I hope this is clear. Clear? So in case if you have any doubt, just watch it again. Go back and watch it again. Let's see the next one. Great. Again, another problem from relative velocity in 2 dimensions. Two boys are standing at the ends A and B of a ground. So let's say this is end A and this is end B. And the separation between both is given here, given where AB is A. So AB is A. This is our A, correct? The boy at B starts running in a direction perpendicular to AB. So let's say this person starts running in this particular direction. Okay, great. With the velocity V1. So let's say this is V1. The boy at A, the person standing at A starts running simultaneously with the velocity v and catches the other in time t. So let's see, if you are moving in this particular direction, right, you will never catch him, right? You have to move in this particular direction, then only you will catch him. So if this boy is moving in this particular direction, A is going from this particular direction, let's say at this point they both meet, correct? Okay, so let's say at point C they both meet. A is going with what speed? V, and B is moving with what speed? V1, correct? So let's figure out, this becomes a triangle. So let's figure out what is the value of AC, right? Both of them reach at the same time. If both of them reach at the same time, what's the value of AC? AC will be equals to velocity in time t. Okay, velocity into time is distance, right? And similarly, BC will be velocity V1 into t. Using Pythagoras theorem, V square will be equals to Pythagoras theorem, length, not the velocity. You have to be very careful. So AC, that is our VT square, equals to V1T square plus A square. I hope this is clear. Hypotenuse square equal to perpendicular square plus base square. Let's expand it. It will give us V square T square, V1 square T square plus A square. I hope this is clear. Okay, let's take this t on the other side and take common. So first let me take it on the other side. V square T square minus V1 square T square equals to A square over here. And let's take T square common here. So taking T square common, this will give me V square minus V1 square, and that will be equals to A square. I hope this is clear, right? Clear it is. Now let's take this whole thing below this. So T square will be equals to A square upon V square minus V1 square. And taking the root, A square root will give me A, and this whole thing will be under the root, V square minus V1 square. This is our time. So correct answer for this is root of A upon V square. Oh, they have not taken out the root. So correct answer is option D. I hope this is clear. Okay, understood? Quite simple problem from motion in, relative motion in 2 dimensions. Let's see the next question. Great. We have another problem from river boat problem. The width of a river, width of the river. So let's say the river is this one. Let me draw it for you. This is our river over here. Let's say this is our river. And the width of this river is how much? Width of the river is 1 kilometer. So this is 1 kilometer. Great. The velocity of boat or swimmer, similar thing, 5 kilometer per hour. Fine. The boat covers the width of the river in the shortest time. What is the shortest time? Time is 15 minutes. If it is in minutes, let me divide it by 60 and make it hours. So 15 fours are 1/4 of an hour. Okay, great. Then the velocity of river stream will be how much? Okay. So velocity of river will be in this direction. Okay, VR. Clear it is? I hope this is clear. And here the shortest time, which means this velocity, okay, this is our velocity of boat, which is given. Okay, velocity of river is, so shortest time is given, that is this much. So if I divide both, okay, which one? This is the shortest time, right? Yes, 15 minutes is shortest time, the time taken to reach from any point A to point B. Okay, the shortest time, this one, okay, is 1/4 of an hour. And what's the distance here? 1 kilometer. We can find a speed. So velocity here or speed here of boat with respect to river will be equals to how much it will be? It will be 1 kilometer upon 1/4. That is equals to 4 kilometer per hour. Now this 4 kilometer per hour is velocity of boat with respect to river. Clear it is? With that velocity, you are going from A to B. So A to B, perpendicular direction. Okay. Now this time be very careful. Perpendicular direction, the velocity is 4 kilometer per hour. Okay. And this velocity is velocity of a river, VR. Correct. And this is our velocity of boat, which is how much? 5 kilometer per hour. Correct. Yes. Now We can use I cap, J cap also, or we can directly use velocity. This is resultant velocity here. So velocity of boat, which is 5 square, must be equals to 4 square plus velocity of river square. Correct it is? I hope this is clear. So this we will use magnitude square. So 5 square is 25, 16 plus VR square. So taking 16 on the left hand side, it will be 9, which is equals to velocity of river square. So velocity of river will be 3 kilometer per. I hope this is clear. Okay. Twice such question has been asked in the previous years. Okay, from NEET. Let's see the next question. Great. A person swims in a river aiming to reach exactly opposite point on the bank of a river. His speed of swimming is 0.5. So velocity of swimmer is 0.5 meter per second. Velocity of swimmer. Be very careful. At an angle theta is 120 degree. Okay, great. With the direction of flow of water, the speed of the water in the stream. Okay, let me just draw this. Okay, rough diagram. So let's say this is our river. This is in this direction. Okay, I'll just draw a rough diagram here. Let's say it is moving in this direction. This is our velocity of river, right? VR. Velocity of river will be in this direction. Okay. And the person is moving at 120 degree with this. So 120 with this will be, obviously this will be in this direction, right? This will be velocity of the swimmer. Yes, correct. Okay. And if this is 120, we can make a perpendicular direction. This is the shortest path. Okay. We have to reach from any point A to B in the shortest path. So this will be our 90 degree. And this will be how much? So this will be 30 degree, right? 90 plus 30, 120. Yeah. And if this is VR, even here if you make, this will be our VR, velocity of river. Correct? So if that angle is 30 degree, we can use sine 30. How much is sine 30? So sine 30 will be equals to perpendicular. What's the perpendicular here? Sir, VR. We have done one problem before, VR. And what will be our hypotenuse? Sir, hypotenuse is velocity of swimmer, which is given in the problem, right? So how much is sine 30? So sine 30 is half. Velocity of river, we don't know. We are looking for that. And what is Vs? Vs is 0.5. Let's take the 0.5 that side. It will be 0.5 by 2. That's our velocity of river. Correct. So this will be how much? It will be 0.25 meter per second. That's our velocity of river. I hope this is clear. Is there any option? Yeah, option C is correct. Okay, clear it is. So this is velocity of swimmer, velocity of river, and velocity of swimmer with respect to river, right? So this is our shortest path. Let's see the next question. Great. We have another problem. A particle moving in a circle of radius r. So let's imagine a circle. This is our circle. And this is our radius r. Great. Okay. A particle moving in a circle of radius r with a uniform speed takes a time t. So time period is t. Fine. To complete one revolution. To complete one revolution, how much time is taking? T. And that t must be equals to how much? Okay, that we will find within a minute because we are not given with the velocity, right? Uniform speed they are saying. So we'll assume it later on. Complete one. If this particle were projected with the same speed at an angle theta to the horizontal, the maximum height achieved by the particle is 4r, right? The question is the angle of projection is how much? Let me explain you the problem. Okay, the problem says if you are having a particle and it is moving in a circular path of radius r with time period t, correct? Then the velocity of this particle here is, let's say v it is. With that same velocity, if you throw the particle, project it at certain angle, it achieves a height of 4r. Find that angle. Clear? So let's go step by step. First of all, the time period is given as t. So let me keep it as t. What will be its velocity over here? So velocity will be equals to, or speed will be equals to 2 pi r by t. I hope this is clear. Sir, why 2 pi r? When it is moving in a circular path, its distance traveled is 2 pi r and time period is t. So speed will be 2 pi r by t. With this speed, it is being projected, okay, at certain angle. What is the formula for maximum height achieved by a particle? So this is u square sine square theta upon 2g. I hope this is clear. So from where you got this? We got this from projectile motion, right? So let's substitute it here. So u is this, h is 4r. The maximum height achieved by the projectile is 4r. U is nothing but 2 pi r by t whole square sine square theta whole divided by 2g. I hope this is clear. Okay, let's rearrange them and get it in one of the option. So taking this on the left hand side, it will be equals to how much? 4r 4r, and taking this t square on the left hand side, it will be t square. Taking this 2 pi r whole square, what is 2 pi r whole square? 4 pi square r square, down 4 pi square r square. Taking this 2g on the left hand side, into 2g, and what are you left with on the right hand side? Sine square theta. I hope this is clear. Clear? Let's see what is cancelling out. 4 is cancelling out with 4, r is cancelling with one of the r. So you got 2 gt square upon pi square r sine square theta root under, so that will give you sine theta. Let me repeat again, t square and g, that is you left with, and also 2 is there, correct? So 2 gt square, and here pi square and 1 r is left, so pi square r, correct? And here I took the square that side, it became root. Clear? Now there is no root here, so they have written this root as power half. So 2 gt square upon pi square r whole power half, correct? And taking this sign on the left hand side, it becomes sine inverse. Taking this sign on the left hand side, it becomes sine inverse. We have discussed it before, right? From inverse trigonometry. So this becomes sine inverse 2 gt square by pi square r whole power half. 2 gt square, sorry, 2 gt square by pi square r. Now this r should be not in the power, it should be properly written here in multiplication, whole power half. So option C is clear. Okay, 2 gt square by pi square r whole power half. Let's see the next question. Great. Our next problem says two particles A and B are moving in a uniform circular motion in concentric circles. Now let's imagine concentric circles. This is first circle, this is second circle, right? There are two circles, okay, with radii RA and RB. Let's say this is our radius RA and this is our radius RB. Fine, it is, okay. Next, with velocity VA and VB. Great, VA and VB, they both are traveling. The time period of rotation are same. So time period is TA and TB, and this is given here as TA is equals to TB. If the time period is given equal, okay, rotation is same. The ratio of their angular speed. Now we know that angular speed omega is nothing but 2 pi by t, correct? Angular speed is 2 pi by t. So if we are looking for angular speed of first one, it will be 2 pi by TA, and the angular speed of the second particle will be equals to 2 pi by TB. If you divide both of them, you will get omega A by omega B, and that will be equals to TB by TA. And what's the value of TA and TB? So they are equal. So this must be cancelling out, and you left with omega A by omega B, that is 1 by 1 or 1:1, which is 1. Okay, option A is correct. Clear? So they don't depend on, they are not depending here on VA and VB or RA and RB. They straight away depends on time periods. Clear? Let's see the next question. Great. We have another problem. In the given figure, acceleration A is 15 meter per second square. Great, 15 meter per second square, that's our value of A, and this is our resultant acceleration. I hope you are familiar with tangential acceleration and radial or centripetal acceleration. So here it is resultant acceleration. A is 15 meter per second square, represents the total acceleration of a particle moving in the clockwise direction. Okay, clockwise direction is here in a circle of radius r, which is equals to 2.5 meter. Great. At a given instant of time, the speed of the particle is, we have to find the value of v, correct? Now you can solve it using tangential, but you require time and other stuff. Here we will make use of straight away centripetal or radial acceleration. So if this is this is A here, then what will be our angle theta here? Angle theta is 30 degrees. So what will be this component? So this component towards the center will be A cos 30 degree, correct? This vector will make a component along the center O, which is A cos 30, and this A cos 30 is our radial or centripetal acceleration. So our A cos theta is A cos 30 degree is centripetal acceleration, and that is equals to V square by R, correct? We know this. This is our centripetal or radial acceleration, that is equals to V square by R. Okay. Now A is how much? 15. Cos 30. How much is cos 30? Sir, cos 30 is root 3 by 2. I hope this is clear. Now we are looking for the speed of the particle, which means V square we are looking for. So V square, and R is how much? 2.5. I hope this is clear. Clear it is. Now let's cross multiply and simplify. So v square will be equals to 15 into root 3 by 2 into 2.5, correct? Let me remove this point, you will get here 10, okay? And 5 threes are 5 twos are, correct? And 25 root is 5 and 2 root is how much? This will be 2, and 3 to the power, how much it is? 1 by 2, and whole 1 by 2, 3 to the power 1 by 4. Okay, approximately that we can skip it here. Okay, we can leave it here. This will be our approximate answer. Now these days they give you even calculator, so you can use it and figure it out, or otherwise substitute the value of root 3, approximate it as 1.7, and find the value of root of 1.7. Approximately you can find the value. Okay, so that is our final result for this problem. Let's see the next one. Great. Our next question says a particle moves in a circle of radius 5 centimeter. Okay, radius of the particle is 5 centimeter, which is equals to, I'm just removing the centimeter and make it here only 10 to the power minus 2 meter, because the answers are in meter. With a constant speed and the time period is 0.2 pi second. The acceleration of the particle we are looking for, right? So we know that acceleration A is nothing but v square by r, correct? And v here, v is nothing but 2 pi r by t. So 2 pi r by time period t whole square by r. Or you can write it here as 4 pi square r square upon t square into r, correct? 4 pi square r square upon t square, and this r was there. So one of the r will get cancelled and you left with 4 pi square r upon t square, correct? Okay, let's substitute the values. So here it will be 4 pi square, and what's the value of r? So r value is 5 into 10 to the power minus 2. Great. And what's the value of t square? So first put the value of t, which is 0.2 pi whole square, correct? Let's expand it and we will get here acceleration here as, acceleration here is 4 pi square into 5 into 10 to the power minus 2 whole divided by 0.2 square, 0.04 into pi square, correct? When you remove this point, you will get here 10 to the power 2. This 4 gets cancelled with 4, pi gets cancelled with pi square, and 10 to the power minus 2 cancelled with 10 to the power plus 2. Clear? What we left with? 5 meter per second square. That will be our acceleration in this particular case. I hope this is clear. Okay. So we are using straight away centripetal acceleration. A is equals to v square by r. Okay. I hope you are familiar with this formula. Velocity is nothing but 2 pi r by t, and we substitute and we get the formula. Direct answer means there is nothing you have to worry about. Straight forward direct problem. Let's see the next one. Okay, a particle of mass m is revolving along a circle of radius r. So let's say this is our circle and this is our radius r, and the particle has a mass m. Another particle of mass small m, okay, this is m, is revolving in a circle of radius small r. Let's say this is small r. Okay, if the time period for both the particles are same, so ta equals to tb or t1 equals to t2, the ratio of their angular velocity. We have just now done one problem that angular velocity simply depends on time period. So omega 1 will be 2 pi by t1 and omega 2 will be 2 pi by t2. It doesn't depend on r or m, correct? So when you divide both the ratios, you will straight away get 1. Omega 1 upon omega 2. 2 pi cancels with 2 pi, and t1 and t2, they both are equal. So this will give you 1. Option A is correct. Clear it is? I hope this is clear. Let's see our last problem from motion in 2 dimensions. In the next lecture, we will start with laws of motion, right? So let's see the last one. A body is wheeled in a horizontal circle. So let's say this is our horizontal circle over here, okay, of radius 20 centimeter. Okay, fine. So this is our r 20 centimeter. So I'm just putting here 20 into 10 to the power minus 2. It has an angular velocity of 10 radian per second. Omega is 10 radians per second, standard units, radians per second. What is its linear velocity at any point? So v equals to omega r, correct? Omega is nothing but 10. R here is 20 into 10 to the power minus 2. That will give us 2 meter per second. Clear? Option B. Okay. So we have covered all the PYQs including the last year. In case if you have not watched the previous lectures, the link is in the description, playlist is in the description. We will see our next chapter, laws of motion, in the next video. Clear?